Assalamualaikum and good day. Today I would like to introduce chapter 8. We continuing from the chapter 7 from week 9. We already done about the electrical charge and electric field. Today we go to electric currents and resistance. So in the topic of chapter 8, we'll cover the electric battery, electric current. In Ohm's law, we have resistance and resistor, resistivity, electric power, and power in the household circuit, alternating current, macroscopic view of electric current, and superconductivity, electrical conduction, and nervous system. Okay, without delay the time, we try to discuss first topic, electrical battery. As we know, the electrical batteries come from the reaction of chemical within two different material with different noble level. For example, we go to carbon electrode with the zinc, and then we need to material as electrolyte. We call electrolyte liquid or solution. In this case, for example, we use sulfuric acid within the carbon electrode and zinc. So which material have the high noble, we call as electrode, and then electropositive, and then with the low noble material level, we call in the negative. So by this condition, so electron will jump from the higher to the lower of noble material. In this case, the carbon is a higher, react as a positive condition, positive electrode, and then react into the low of noble material. So by this reaction, we will create the electricity. So the electricity will flow from the negative actually to positive. But in the reaction, positive will release the electron to reaction to negative electron. Okay, battery transform chemical energy into the electrical energy. Chemical reaction within the cell create a potential difference between the terminals by slowly dissolving them. This potential difference can be maintained even if a current is kept flowing until one of other terminal is completely dissolved. Okay, this dissolve is by chemical reaction. Okay, this one is example, other example of battery in the low, maybe low of voltage. This one we commonly use in the electronic, like the watch or the toys, anything. So several cells connected together make a battery, although the new refer to single cell as a battery as well. So actually, in a single battery itself, created by the electrolyte, and then also the main is in the positive of terminal is as the electrode positive. This one will create by higher noble material. Okay, if we refer to formula of electric current, I is equal to Q over to T. Q is mean charge, the flow charge of the atom. So every atom will consider every time 1 second. So if one coulomb, the unit of the electric charge is coulomb, for 1 second. So 1 in the ampere, because this one is a current ampere. 1 ampere is considered equal to 1 of coulomb over to 1 second. Okay, so the instantaneous current is given by dou Q or dou T. So depend on the condition of Q we measure. If we Q in the 2, 3 of Q discharge, so we try to measure the time. So unit electric current ampere equal to 1 ampere equal to 1 coulomb per 1 second. Okay, as I mentioned before. So consider 1 ampere equal to 1 coulomb over to 1 per second. So electric current, a complete circuit is one where current can flow all the way around. Now that the schematic drawing doesn't look much like the physical circuit. So actually, one circuit complete if have a connection from the positive into the negative by the conductor. Okay, so if we check and look into circuit figure, we have the positive and the negative with one link of connection. So if we put the device within the positive and negative as a bulb, so bulb will be give a signal on because of the current is flow. Okay, we have an example here. Example 1, current is flow of charge is steady current. If steady current have 2.5 ampere exists in the wire for 4 minutes, so the question is how much total charge pass by a given point in circuit during those 4 minutes? And the second question, how many electrons would this be? So we refer to the equation of I, current, equal to Q over to T. So we have here Q is the question. So the I as current is 2.5 ampere, and then we have time equal to 4 minutes. Because the unit should be in the second, should be convert for 4 minutes into the second. So we try to calculate 240 seconds if 4 minutes. So just input inside the equation from the Q equal to I times to period times. So we got the answering is for 600 coulomb. Okay, and then second question, the charge is 1 electron equal to 1.6 times to 10 power negative 19 coulomb. So just use divide from the coulomb by the every charge of electron. Okay, we go to next slide. Electric current, conceptual example 8.2, how to connect a battery. What is wrong with each of the schema shown for lighting a flashlight bulb with a flashlight battery and single wire? So we have a first figure is incorrect because we don't have the closed circuit. Because after the positive into the bulb, we should be continue the flow into the negative, correct? And then in the positive also close, but the negative is still open, so cannot close the circuit. And the last figure is correct because the circuit is closed within the negative and positive circuit. Okay, so the correct answer is the last figure. Next slide. By convention, current is defined as flowing from positive to negative. Electron actually flow in the opposite direction, but not all current consists of electron. Okay, actually, electron will jump from the negative into positive. But in the conventional method, also describe electric circuit current is come from the positive into the negative. But actually, the electron inside of the material is jump from the negative into the positive. Yeah. So the opposite way, actually, the inside of the material. Resistance and resistor. Okay, experimentally it's found that the current in a wire is proportional to the potential difference between its end. So actually, current and the voltage is proportional because of the resistance will reduce the voltage itself. So because of resistance influence the final result of the voltage and the current, so the formula is current equal to V over to R, or V equal to I times to R, because the voltage is influenced by the resistance. It's not always similar to the current. So, but proportional to the I, the current. If you plot the graph within the V and I, so should be is linear. But because of the resistance influence into the current and voltage, so should be have the slope. Okay, Ohm law resistance and resistor. For example, next example, A3, current and potential. Current enters a resistor R, as shown in the figure. Yeah. Is the potential? The question is the potential higher at the point A or point B? The question 1. And the question 2, is the current greater at the point A or the point B? So the first question, A, should be the voltage potential is higher in the position A compared to position B, because as we know, the voltage will flow from the higher into the lower. As we have mentioned, the arrow from the left to the right, it's mean the flow from the higher into the lower. The same as the condition for the current for the question B. So because of the proportional, I current is proportional to the potential, should be the higher also in the position A. Okay, next example, flashlight bulb resistance. A small flash bulb draws is 300 milliampere from the its 1.5 battery, 1.5 voltage battery. The question is, what is the resistance of the bulb? And then the second question, if the battery becomes weak and the voltage drop to 1.2 volts, how would the current change? So we go to the answering. So for A, we use Ohm law in a find R equal to V over to I. So R equal to 1.5 divided by 0.3. So the answer is ohm. And then go to the second question. Resistance stays constant. The current will be approximately I equal to V over to R. So the final answering is 0.25 ampere. Okay, I hope this one is clear. Okay, now we learn how to understanding about resistance and resistor code. Understand that resistors are manufactured for use in electric circuit. They are color coded in to indicate their value of precision. So every resistor giving the reading performance of device, resistor device. So the first color we mention the digit, the number of the resistor performance. Then the second digit will mention something we can see, and then multiply is a multiplier if the have the power more than the 2, 3, and 5 of power should be need to multiplier. And tolerance, this one is performance minus or negative will differentiate within the should be a measure. Okay, as I mentioned before, what the first color mentioned, the first color we will variate from the black until to no color. So variate. So the black refer to number 0. So brown is refer to number 1, and red and so on. You can see by yourself. And then the multiplier. Multiplier is more than the power of 1, more than the power of 2. This one is the power of performance. And about tolerance, if the performance is less than the mentioned number or more than the mentioned number. So tolerance is will be give allowed from 1% until 20%. Differentiate, differentiate. Okay, some clarification. Battery maintain a nearly constant potential difference. The current varies. Correct. Resistance is property of material or device. Correct. So resistance will be contribute in the material by material or device. Current is not vector but have a direction. Current and charge do not get used up. Whatever charge goes in one end of circuit come into the other end. So actually, current is to be closed system. Okay, we go to resistivity. The resistivity, the resistance of wire is directly proportional to its length and inversely proportional to cross section. So actually, resistance will be increased by increasing the length, so the L. So but will high performance if have the area higher. So area is actually is opposite to the resistance, but proportional into the length. So the constant rho, the resistivity is characterized by the material. So the rho is contributed by material type. If the different material, different of resistivity of material. Okay, this one is table 25.1 will give the example of resistivity every material. Silver, the resistivity is 1.59 times 2, 10 power negative 8. This one at the temperature of operation. Okay. Okay. Okay, we have an example here. How the speakers wire. Suppose you want to connect your stereo to remove speakers. The question A, if each wire must be 20 meter long, what diameter copper wire should you use to keep the resistance less than 0.1 ohm per wire? The second question, if the current to each speaker is 4 ampere, what is the potential difference or voltage drop across each wire? Okay, let's check the solution. Solution, we solve for the area first. The area of the wire. So we have length as input, and then the resistivity, and then also resistance. So we have wire area is 3.5 times 2, 10 negative 6 meters squared. And then after that, the cross-section area wire is related to the diameter by A equal pi d square over 4. The diameter must then be at least D in 2.1 millimeter. So from Ohm law, V equal to I times to R. So now we got the voltage is 0.4 volt. Okay, clear for the question example of 5. Now we go to other example, stretching change resistance. Suppose a wire of resistance R could be stretched uniformly until it was twice its original length. What will happen is resistance. So what happens if the wiring is increased twice? So what happened to the resistance? So resistance is become twice from initial condition because of thicker wire has less resistance. So we reduce the area of the wire. So what happen? Resistance will be increased. So for other topic is how to measure material, resistance of material by temperature. Okay, so actually the resistivity increased by temperature. So if material is have higher temperature, like device, our device have the sometime after certain time of operation will increase the temperature. So actually will increase the resistivity. So the formula is rho T equal to rho O, initial rho, times to 1 plus alpha times to differentiate or delta T. Yeah? So as we know, the alpha is temperature coefficient of resistivity, as mentioned in the table 25 just now. So we try to solve the problem by using this formula. The variation in electrical resistance with temperature can be used to make precise temperature measurement. Platinum is commonly used since it's relatively free from corrosive effects and has a high melting point. Suppose at 20 degrees Celsius, the resistance of platinum resistant thermometer is 164.2 ohm. When placed in a particular solution, the resistance is 187.4 ohm. What is the temperature of this solution? Okay, we go to how to solve and how to use this formula. So back to the formula that was influenced by temperature, and then we just derive this formula until we get to simplify to solve this question. Okay, so now we already simplify of the all question, and then just input inside of the equation, and then we got the T that work in the of the system. Okay, I hope this one is very clear. Okay, now we go to topic electric power. Power is a kinematics, is energy transformed by device per unit time. So if we refer in the energy, mechanical energy, we will refer to energy of kinematic. Yeah? Energy kinematic, such as MPV, yeah? MPH, yeah? Same like this. We need the motion to measure the power. So in this case of electrical, we use P work. Work, du is work over to time. So we will measure by time. In the mechanical work, we will use joule. But in this case, we will use watt. Okay. If we derive or work in the electrical, U is equal to Q time to V. Okay, Q is electrical charge and V is the potential voltage. Then we can simplify this formula by P equal to I as current time to V, because Q over to T is equal to I, or current, because the charge coulomb divided by time is equal to I. Okay, we can simplify by other condition. Yeah? If IV, we derive V is equal to IR, so we can simplify I squared times to R. If we derive V equal, I is equal to V over to R, we can simplify V squared over to R. Okay, depend on known parameter. Okay, we have an example here. We are already in the 8. Example 8 about headlight. Calculate the resistance of 40 watt automobile headlight design for 12 volt. So calculate the resistance first. So resistance V square over to P, because we have a P and potential, so we can got resistance. Yeah? And this is the resistance when the bulb is burning bright at for T watt. Yeah? When the bulb is cold, the resistance is lower. And since the current is high, most bulb burn out with the first turn on. Okay. Actually, this one is other topic. Yeah? What you pay for on your electric bill is not power, but energy, the power consumption multiplied by time. So we have measuring energy in joules, but electric company measure in kilowatt hours. So the company electrical, they will calculate by kilowatt hour. So we can convert kilowatt hour to joule. Okay, next example, an electric heater draws a steady 15 ampere on 120 volt potential volt line. How much power does it require, and how much does it cost per month, 30 days, if it operate 3 hours per day, and the electric company charges 9.2 cents per kilowatt. Okay, solution is P equal to IV, because we have I and V, so we can calculate the power. To operate per month times to 30 days. Yeah. So we can calculate kilowatt into the to money. Yeah. This one other example, electric power. Lighting is spectacular example of electric current. Yeah. There is much variable to lighting bulb, but a typical event can transfer 10 power 9 joule of energy across a potential difference of perhaps 5 times 10 power 7 volt during a time interval about 0.2 seconds. Use this information to estimate A, the total amount of charge transfer between cloud and ground, B, current lighting bulb, and C, the average power delivered over to 0.2 seconds. Okay, how to calculate? Energy equal Q times to V, so we can got the final solution. And the current in 0.2 second is I equal to Q over to T. And then how about the power? Power, energy over time. So we can got the final answer, which can also be found by P equal to I times to V. Okay, it's okay. Both method is similar. Power in household circuit. The wires used in homes to carry electricity have very low resistance. However, if the current is high enough, the power will increase and the wires can become hot enough to start a fire. To avoid this, we use fuse or circuit breakers, which disconnect when the current goes above a predetermined value. So actually, we will discuss if a power supply higher and then power consumed higher. So the wiring as connecting within the device and the power supplies is not enough to support the power electrical. So we use the circuit breakers. In this case, we will use fuse. Yeah. Okay, we'll check what is the fuse. Okay, we will fuse. We'll input inside sometime in the plug. Every plug. If the plug supply or absorb higher energy, but the wire cannot support, so the fuse will break or destroy. Okay, this one, how the schematic, the switch work in the current use in our house, by connecting, how to connect within the positive and negative. Okay, understanding about the fuse fuse work, we go to example 11. We can see, refer to the figure, the question is, will a fuse blow determine the total current draw by all the devices in the circuit shown? So we have head dryer here with a 1200 watt stereo receiver, 350 watt electric heater, 1800 watt, and the bulb 100 watt. So the question is refer to fuse, this one. Can support by 200, 120 volt can be support or not? Okay, we try to solve this problem. So we will use the formula I equal to P over to delta V. So we have all input here, every device. So P, we have any device, we have varied from the 100 in the bulb, yes. And then also we have 1100 for the heater and so on, until to we calculate all device and then determine the ampere of current. Is more than 20 because we supply in our house is only 20. So the question is more than 20. So should be fuse will blow. Okay. And then the last question, I think 12. Your 1,800 watt portable electric heater is too far from your desk to warm your feet. Its cord is too short. So you plug it into an extension cord rated at 11 ampere. What is the dangerous? Yes, I can say yes because we can calculate by this formula similar, and then we can get the ampere is 15 more than a wire ring cord rate. Yeah, so this will be dangerous. Okay, to close our chapter 8, we make some summaries here. So actually, this summary is will use for your attendance also. Please submit your summary in this week. So first summary, a battery is source of constant potential difference. Electric current is a rate of flow electric, conventional current, and so on. Resistance. Okay, you can see by yourself and make a summary by yourself based on your creativity and submit into the chapter, week 10, and we'll consider as your attendance. Okay, that's all. Our chapter 8. See you in the chapter. Next chapter is 9. Yeah.